So, how to write Perl extension in Rust, and let's start with why. Perl is a wonderful language, very high level, allows you to do things easily, quickly, but it has one drawback: it's kind of slow. Most of the time it doesn't matter, but things like parsing binary protocols, doing complicated math, cryptography is taking forever in Perl. For that cases, Perl has a C API and a set of tools which allow you to write extensions, code that runs inside Perl in C. And that is collectively known as XS. All is good, but we're writing Perl exactly because we don't want to write in C. It's hard, it's error-prone, and it can take your whole interpreter with you if you make a mistake.
Yeah.
Very careful about things you do. You have to track a lot of moving parts. And inspiration actually came from Brian Strostrup this fall. He published a paper where he said, being careful is not enough, and it takes time, and it doesn't prevent bugs, so we have to do better. Although I believe C++ would not be an answer to this problem, to the problem of writing XS that doesn't crash Perl interpreter, but Rust will actually be. Rust is a new language that aims roughly the same niche as C++, but it, by design, has a strong focus on memory safety, not allowing programmer make mistakes from improper use of pointers. Let's start with a motivating example. Here is a small XS function written in C, and despite being only 4 lines long, it can crash in many different ways, taking your Perl interpreter with it each time. One big source of the problem is null pointers. It's a very common idiom in C to represent something that's not there. For example, getID on line 6 will return null pointer if the array variable is not defined in the program. Likewise, fetch will return null pointer if the array element is not there, if array is too short. And of course, it will crash if the array pointer is not null, so we have to check for it. Likewise, on line 9 we read SVT pointer, and if the array is too short, it will crash. And also another kind of problem, because we have call to that routine on line 8, it can do things to array, and that will crash our program too, because Perl doesn't know we have SVP hanging around. So it will free memory, again, everything goes in flames. This is a Perl part, and of course routing does that, so we need to do something. To fix this, we need to insert a lot of checks. We need to check that SAV is not null before fetching an element. We need to check that SVP is not null before reading it. And we need to read SVP as soon as possible, because it can go away at any moment. Let's start with null pointers. Rust has this enum type, and if you did see, it will look familiar. It's here we define type drinks, and it can be one of the two things. It's a cola or a beer. We can make a variable and assign it one of the values, but nothing else. Only these two are acceptable. In Rust, enum variants can also have data associated with them. Here, cola is still a simple value, but beer has a string value associated with it, which says what kind of beer it is. So we can create a variable that has a beer and some string. And the only way Rust allows us to get the string is to check that drink is actually a beer and nothing else. One way to do this is match operator. On the left side we have enum variants. On the right side, after the arrow, we have the code that will be executed when that branch matches. And on line 8 we also have kind variable that will be assigned the string beer has, and this kind variable is only accessible to the beer branch. Cola cannot see it, can never touch the wrong data that's not there. Sounds like what we need for null pointers. So if we have an enum, with null and not null, and not null has a pointer. And we take care to put not null, only not null pointers there. Developer can no longer dereference them because they're not there, but we still communicate them the absence of value. And this is very common pattern in Rust, so common that there is a standard library type just for that. It's actually a whole series, infinite series of types, because of the T in angle brackets on line 1. It's like called generic type. You can put anything there. You can put option of integers, you can put make options of pointers, whatever you want. And we use standard library because it has many useful methods. And these methods should look familiar because most of them have direct equivalents in Perl. So not defined can be checked with isSum. Expect will throw runtime error if there is no value. And unwrap or returns default value if there is no value, or whatever option contained if there is some. Here, how would be the motivating example look like if it was written in C? We have let keyword introduces new variables, then comes the variable name and its type after a column. Types are optional, I just spell them out for clarity. And then we have get AV again, it gets a string with a variable name. And on the next line, we try to read from AV. But since it's an option, it doesn't have fetch method, so compiler tells you it doesn't work. To fix this, we just need to check for errors, and then we don't need options anymore in our code. Here we use expect. Normally you would do something else because expect is a runtime error, and you may want to communicate absence of values in some nicer way. Dangling pointers. This comes from when you have a pointer and the memory is freed, then you cannot longer read it because it will crash your program again because the operating system tells you this address is not valid. Or worse, you get junk, which is even worse. Here, if we undef array between getting value from AV fetch and reading it, our program goes down in flames. To deal with that, somehow we need to tell developer not to delay reading the array element too long, not to allow him to put any code in between these two actions. But on the other hand, we don't want to enforce unnecessary runtime requirements. Say if he only wants to read an integer, we don't need to make that costly operation. We don't want to copy SV or increment its reference count. That's how we tell Perl to keep the value around long enough not to free it. And in this case, actually, if you do undef on an array, it just frees the array. And you cannot prevent it anyway. So incrementing reference count doesn't work. We need something else. And this can be done with traits, with application of traits. Trait is a way you can tell the compiler what methods your types implement, what methods they have, what you can call on them. So here we define two simple structures, squares and circles. They have different attributes. And a single trait, area, which has a method area that computes area of the shape. And we can implement this trait for two different things, for squares and for circles. There is fine print, but you can implement trait for anything. You can implement trait for building types. You can implement traits for maybe pointers. And on line 19, we have a generic function. It's a function that, again, it's many functions that can take all kinds of types, but only types that implement area, because we have area behind the type parameter. On line 19, in angle brackets, we have this specification that only types that implement area will be accepted here. And then we can call it the method. So what do we want is to somehow make the conversion happen, but allow the developer to specify what kind of conversion he wants when he gets a value from the array. And we can do this with, by defining a trait that says something can be converted from SV pointer. Something can be created from the SV pointer. So we have a simple trait with a single method that takes SV pointer and returns something. Later we have the implementation of from SV for integer numbers and for floating point numbers. They just put the standard access macros for converting SV into an integer, into the number. And later on line 12 we have generic function abfetch that says I will return any type as long as it can be produced from an SV pointer. We then on line 13 we just get the raw pointer from Perl and dispatch it to the type user gave us. It is the caller of the VFetch that decides what type T will actually be. So on line 18, we have abfetch that returns an integer number. Compiler knows that T is ID and will dispatch to the method on line 6, and it will never confuse it. And in fact, it will be just line 18 will be replaced with just SVID from the pointer. Of course, there are cases where developer may want an SV pointer really, but then we have to do something with it. We need to somehow communicate Perl that this variable programmer has a reference to that variable, and if routine is called now, it should not be freed because we still have it. There are two ways to do it. We can increment reference count, or you can copy. When you get a variable from an array in Perl program, it is usually copied. That's what I did for Rust bindings, but there is really no good reason to do so. So putting all things together, this is how the original program works with all the checks inserted. We have on line 4 we have get AV that returns v. We check that it is not null. We get an element from that array. Again, we check that it is not null. Here we get SV, so it is copied. Then we can safely call routine because now we have our own basically number. Perl will not do anything with it until it leaves. And then we can convert it to an integer and return it. And then once SV variable goes out of scope, it will have its reference count decremented automatically. We don't have to worry about it. Right, problems. Of course, this is a new thing. It has lots of problems. One is exception handling. Both Rust and Perl has their own ways to do exceptions, and they're totally not compatible. So it will probably, I didn't solve it yet, but this will probably introduce some runtime overhead, because we need to check and make sure they don't step on each other's toes. No direct access to Perl internals, since bindings are generated only for public Perl API, and in CXS you can have access to everything. You can call any hidden method, any implementation, exploit any implementation detail Perl has. Some modules do that. You cannot do that in Rust because, and Rust supports far less platforms than Perl, so maybe it's not a very, even if it was done, maybe it wouldn't be a very good choice for CPAN. But if you have some code that runs and want to have some more confidence than you can get from C access code, that might be an option. Questions? Yes?
Isn't the inaccessibility to internal, non-documented, non-public APIs arguably a good thing?
Depends.
On what your CPAN ID is? It depends on what your CPAN ID is?
Yes, mostly.
It would seem like that would be a very good thing, because 524 may decide to change the API for that, remove it. I think that happened to MathPari at one time way back when, and I don't think the P5P people were very happy about it.
Well,
So it seems like a good thing that you can't go access things you probably
I see
shouldn't.
it's a good thing, but I imagine there are maybe different opinions for this.
I'm pretty sure the last time I wrote XS, and I'm willing to say it's been a while now, thankfully, I had to use quite a lot of undocumented methods just to get ordinary things done, so it seems like quite a limitation.
Undocumented is not the same as it's not API.
Perl has actually a nice thing that helped me a lot. Perl has a nice file, text file in its source distribution that lists all functions it considers public API. And then it separately gathers documentation, so there are some public API methods that are not documented. They're just listed in one long list of undocumented public API methods. I don't know maybe if it was from there, but overall it seems to me that Perl's developers try to define some kind of stable API for writing XS.
You can use dev or quick cover to see which ones get called.
So have you written anything more than just a proof of concept example that allows you to compare Rust and C as a language to extend Perl?
No, mostly because I'm still trying to figure out how this Rust API should look like, because making it not expose pointers changes the shape of it a lot. And that's first needs careful design, and then I cannot really auto-generate it from that text file. So I have very little code written yet. I'm just trying to figure out how to do it safely, and then maybe something bigger. Yes.
Can you go back a few slides to the Rust code?
Sure.
It's a bit weird that you call first getAV and fetch before the expect. So Rust does some magic there, or?
Actually, chained methods. GetAV returns an option, and then I call a method on that option. So it's like one expression on 2 lines.
Oh, okay. So getAV actually returns an option. And
Yes.
Okay.
How did you implement the package foo and sub syntax?
Yes. It's done with Rust macros. They are quite different from what C can do, so we can parse some kind of, you can define some kind of syntax with them.
But how much of that is macro and how much of it is actual Rust syntax?
So everything inside sub between on lines 4 and 9 is just Rust syntax, and XS is just parsing package and loader to create the boilerplate that XSubPP normally does for you in C.
Is there anyone else helping you or trying to work along this Rust?
No, not as far as I know.
See, we use Vikentiy. He uses himself.
Yeah, it sounds like there's a lot of things here to define, to find out, because it's not just hacking until you make it run. There are many things here that you will have to make up your mind on how to approach them.
Yes. So any help will be great.
Yeah, that's the point. Yeah, that's cool.
Then